Hi, and welcome to another Hopper on Microcontrollers video. I'm revisiting SD cards, so using SD cards because it's changed a little bit since I wrote the first, since I did the first demo of this. So let's go have a look. I'm going to show you two different SD cards. I'm going to start with this one from DFRobot, which is a simpler, smaller one. It's like the tiniest one I've seen. And the microcontroller I'm using today is the Pimoroni Tiny 2350. So it's the same chip as the Raspberry Pi Pico 2, but also a tiny device, simple to hook up. SD cards use SPI interface, so the pink pins here. And we're using the default pins that I've got in my board definition for controller 0. So on this second iteration of the Pimoroni Tiny, they've now got SPI 1 and SPI 2, SPI 0 and SPI 1. In the previous iteration, they only had one controller exposed through the pins. Anyway, so we're going to use the default pins. Let me show you what that means. So this is my little sample, as simple as I can make it, for illustrating how to use an SD card in the Hopper file system. The only thing you need to do in terms of configuration is say which board you're using. And in the boards folder, there's a bunch of different boards. If I right click on this, you can see there's some default settings for SPI for the pins. And those are those pins I was talking about. I'll quickly switch back and show you what I mean. So those pins are these ones here, these pink ones. So GP7, 6, 5, and 4. Let's switch back. So there you go, 7, 6, 5, and 4 over here. Here, 7, 6, 5, and 4. What do we need the pins for? Let's have a look. So on this device, it's the default controller, which is controller 0, and the default pins for controller 0 for clock, transmit, receive, and chip select. I then try to mount the SD card, and if it detects one, if it initializes correctly, it'll mount it, and if not, it just won't. And the Hopper uses the built-in flash of your microcontroller for a file system, like all the flash that's not used to. It uses like 1 meg of the flash for uploading your current program into Hopper, into your microcontroller. And then it uses the remaining flash, and the default remaining flash for Pi Pico 2 boards is 3 meg. So you get a 3 meg drive that's rooted at like the root folder. And then the way Hopper works is it'll mount the SD card in a special folder called SD, so /SD/. So if we don't have an SD card in there, and then all this program is doing is recursively walking directories and listing the files in them. So you can have a quick little look at that. There'll be a link in the description to the source code from this sample so that you can do it at your own pace and modify what I've got here and see how you iterate directories in the Hopper file system. It's very simple, similar to C#.NET libraries. So let's build that and then upload it and run it on my microcontroller. I've uploaded into the debugger, and I'm just going to press F5 to run it. And there we go. Mount failed, right? So in the serial output here, which is what the IO write line is, it says it failed, but it's got a bidden folder with a CRC for the currently uploaded program, which is auto.exe, the thing that will automatically run when you reset your microcontroller. And that happens to be our current program right now, Explorer FS. And it's got a temp folder. Might have used that in the past, but there's no SD card. So now let's go and insert the SD card, and then I'll press F5 again. So now we get all the files that I happen to have on my SD card. And it's a FAT32 file system. So if I take that SD card and plug it into a computer that understands FAT32, like my Windows machine, I'll be able to see this drive. I'll be able to see the root folder of my SD card is what we see as SD/ here. So it'll have a folder in it called content, folder called logs. yeah, so that's how you get it working. Now, one of my concerns with this board is that it says it's 5 volts, 5 volt power, right? And I wasn't sure it was going to work as 3.5 volts. So that was one of my concerns. I like the board because it's super tiny. But let's check if it'll work with 3 volt. I mean, with 5 volts. So if we look at our pinouts, V bus is what's, the 5 volt supply from USB. But if I'm going to run this on a battery, for example, I really want it to run on 3.3 volts. So let's see if that's going to work. So I'm going to exit this and unplug my power and move this and plug it back in. So I moved the card over to the 3 volt pin. That's getting 3 volts there instead of 5 now. Let's see if it still works. So if I F5 to load it into the debugger again, my card's still in. So if I press F5 to run, it works. So even though DFRobot says this Fermion SD card is a 5 volt card, it actually runs as 3 volts as well. So just fine. So they don't say that anyway, but it's perfectly fine at 3 volts. I've had no troubles with it. And it's another reason is it's pretty darn cheap. Anyway, second half of this video, I'm going to pause and switch to an AdaFruit card, which has a few more features. Okay, so here's the AdaFruit one. And it kind of says the same thing about 5 volts. It says it runs on 5 volts, but I think it's got a chip that, regulator that takes it down to 3.3, and that's an output, not an input. But we can see how it'll work. As usual, AdaFruit has really good tutorial stuff. And there's an extra pin in here. This device has a card detect pin, which is the feature I was talking about. So let's see how it works. It's a bit bigger. It's a bit bigger than the Fermion one from DFRobot. But it also means it has mounting holes. And like I said, it has a card detect pin. So let's pop the card out. Let's switch back to our program. And I've modified the program slightly. I know I've plugged on in the gray wire, I've plugged in the card detect to GP3. And it's the pin is pulled to ground when there's no card in, and otherwise it floats. So you need a pull up to make it positive when there's a card in. So it's shorted to ground when there's no card in it. So you pin mode input pull up. And now what we can do, and I've made this verbose so that you can see what my intent is, and also Boolean variables in Hopper are initialized to false. Every variable in Hopper is initialized to its 0 value. So I get the card detected, and if that's true, then it'll be not grounded, and it'll go into mounting, which means we won't get what's the benefit of this? We won't get the mount failed message unless the mount actually did fail. In other words, there's something wrong with the card. So if there's no card detected, it's not even going to try to mount. And then I also put in a Boolean for successful mounting. So we only eject, just for writing clean code. We only eject if there was a card. So if there's no card in there, I should just see the directory listing of bin and temp again. So let's see if that's true. We F5 this. And we've got no card in, so we should just see bin and temp. And there they are, bin and temp. So now if I push the card in, and I press F5 again, now we get the SD card as well as bin and temp. And for some extra credit, let's see if we've got turn off optimization, turn off disassembly, rebuild. It's nice to turn off optimization if you want to debug through the original code as opposed to the optimized code. Now we have 5. Now this is how the Hopper debugger works. It's running, across the same serial port here that the device is plugged in. I can press F9 to put a breakpoint there, and now F5 to run to my breakpoint. Let me get rid of a bit of that, make that a bit smaller. There we go. So we can see card mounted is currently false, but digital read returned true. So card detected is true. So that means we're going to go in here. So F10. Now we're going to mount the card, and card mounted is now true, which means we don't go into that error message. We walk the directory. I just F10'd over that, and now I'm at card mounted. So card mounted is true. Step in there, eject it. There you go. That's how the Hopper debugger works. Anyway, the wiring here is really simple. Although the naming has changed for SPI to no longer use derogatory terms like slave. But like AdaFruit has made it quite easy to understand. Let me show you. So their convention is very strongly input and output. So, and they put little arrows in there. So, you know, this is device input and device output, which is kind of nice naming. And if you then can just think in terms of TX and RF, so your DX, they go to your RX and TX. So on this card, there again, you've got RX and TX. They've also got rid of the offensive naming. So the card output is coming to your RX of your microcontroller, and the card input is coming to your is coming from your TX of your microcontroller, transmitting into your microcontroller and vice versa. And the Fermion, I think, still has the old naming. Yeah, they still have MOSI and MISO. But yeah, so just think of it as microcontroller in and microcontroller out, and then match what that means. So microcontroller out means it comes from the transmitter on the microcontroller, and microcontroller in means it goes to the receive on the microcontroller. Clock is obvious, that's SCK on this one, and I think it's CLK on this one. And then the other one is like, you know, they call it, you know, child select or chip select. What do these guys call it? It's still called SS. Yeah, SS, which is, you know, select. And ground and 5 volts. So the ground and 5 volts on both of them, it can be 5 volts or 3.3. They all work with, they all seem to work. And I've tried a few other cards as well. They all seem to work with 5 volt or 3 volt. But don't get confused by this 3 volt. That's an output. This is the input of the power, the one that has the arrow pointing inwards. Yeah, and then the only other extra pin on the AdaFruit one is this card detect pin. There you go. That's how you wire it up. And I used my GP3 for card detect, and I used the default, these 4 ping pins for my SPI interface. Great. Thanks for watching. Don't forget to like and subscribe.